Many a times when you're doing limit problems, you'll come across some problems where there are ratios of two functions, and when you substitute the limit, you get something of the form infinity by infinity, or 0 by 0, or infinity into 0, or something like that, which is undefined, right? So there is a quick rule which is called L'Hopital's or L'Hospital's. I guess it is spelled. I mean, it's written hospital, but it's pronounced hospital. I don't know, but it's L'Hopital's or L'Hospital's rule, which says that if the limit as x approaches a of f of x is of the form infinity by infinity, or 0 by 0, or infinity into 0, or something like that, then then the limit as x approaches a of f of x is the same thing as actually there should be ratios of two functions, right? G of x, let's say, the limit as x approaches a of f of x over g of x is infinity by infinity, or something like that. Then the limit as x approaches a of f of x over g of x is nothing but f prime of a over g prime of a. Okay, so this is very helpful in some limits. As you'll see, some standard limits are can be derived from this rule. So I might do actually, let me do it. Here's a proof of this theorem. Here's a proof. So I haven't done a video on the definition of derivative, but you might know that the derivative of, let me choose another variable. Let's say h prime of x is defined to be the limit as let's say c approaches 0 of f, I keep writing f, h of x plus c minus h of x divided by c. Okay, so this is the definition of a derivative. I'll give you the reason why this is defined to be like this, but just take it for granted just for now. I'll do a video on this. Okay, so according to this definition, then f prime of a will be equal to the limit as again, I'll choose a variable, let's say h, as h approaches 0 of f of what is it, a plus h minus f of a divided by h, right? And using the same thing, g prime of a will be equal to the limit as let me choose another variable now. I'm running out of variables. Let's say m approaches 0 of g of a plus m minus g of a divided by m. So substituting these two values in this equation, I'm kind of proving the theorem. I'm proving that the right hand side will turn out to be the left hand side. So let's divide these two equations. So we'll get f prime of a over g prime of a is if I have a limit of the limit of two ratios, then I can take the limit of the whole ratio. I mean, if I have the limit as of something as of h of x divided by the limit of g of x, then this is the same thing as taking the limit of h of x divided by g of x. Okay, so using that thing there, I can say that this becomes the limit. And now let me make these two into a single variable. Let's say n approaches, or I should keep h approaches 0. They almost look identical. H and n of h approach limit as h approaches 0 of when you divide these two, actually I should have done this as h. I should have done it. I'm sorry. And here. Okay, so this is as h approaches 0 of a plus h divided by h. Okay, so when you divide these two, you'll get the limit as h approaches 0, and the h will cancel out, right? And you'll get f of a plus h minus f of a divided by g of a plus h minus g of a. Okay, so now in this proof I'll assume that this limit is of the form 0 by 0. Okay, I'm assuming that. So usually the limit as h approaches, as x approaches, as x approaches a of f of x over g of x, is it's usually f of a, and mostly f of a over g of a. Okay, so for this to be equal to 0 by 0, I'm assuming that f of a is 0 as well as g of a is 0. Okay, so using that definition, this is 0 and this is 0, right? So this is equal to the limit as h approaches 0 of f of a plus h over g of a plus h, right? Because I assume that these two are 0, that will create one of this kind of infinity by infinity and 0 by 0. So this comes out to be, now as h approaches 0, you will definitely realize that as h is 0, then this is just equal to f of a divided by g of a, right? Because h is 0, so this is just f of a, and this h is also 0, so this is g of a. So we got the left hand side here. From the right hand side, we proceeded from the right, and we use the definition of derivative, and we use that definition. We assume that f of a and g of a are 0. Then we got to the left hand side, right? Because you can see that the left hand side is the limit as x approaches a of f of x over g of x. But I did say that the limit of f of x over g of x, the same thing is the same as this thing. So I proceeded from here, and I got here, right? So you can see that I've done the proof, right? Because if this is equal to this and this is equal to this, then this must be equal to this, right? So I proved it. So this comes out to be f of a over g of a. So this is quite a useful, actually very useful rule, L'Hopital's or L'Hospital's rule, and we are going to use it very much. Actually, there are many standard limits which are proved using this definition. Okay, I hope you like it, and I'll prove some standard limits in the next video using the L'Hopital's rule.